What is up, Flutter devs? Welcome to today's Widget Workshop. A Widget Workshop is a relatively brief live coding exercise where I show you how to build a particular widget or visual effect in Flutter. They typically range from 20 minutes to an hour, depending on what we're building. In the very first Widget Workshop, we paid homage to my roots working on the Nest app. Today, we're going to do that again. When I worked at Nest, one of the screens that I was responsible for was the Nest Protect screen. That's the smoke detector screen. It has a semi-skeuomorphic design at the top that looks like a physical Nest Protect. I always liked that little design detail, so today we're going to create a close facsimile to the Nest Protect hero pattern. In this workshop, we'll create a unique dot pattern, display the center button of the Protect, and even add a green glow. If you really have fun with this workshop, you can even purchase an extended widget workshop that picks up where we leave off and adds a pulsing yellow and a pulsing red glow, which is what you would see if your house were burning down. We also add a dark variant in the extended widget workshop to complement the light version that we create in this workshop. You can find that extended widget workshop at superdeclarative.com. As always, if you enjoy these videos, please be sure to like, subscribe, and to share. And with that said, let's get into the workshop. Welcome to today's Widget Workshop. Today we're going to be creating a hero image that looks very similar to what you see if you open up the Nest app and look at the Nest Protect, which of course is the smoke detector and carbon monoxide detector that speaks to you. And I've always been a fan of the hero image on that screen. It's a kind of skeuomorphic representation of the Nest Protect. It represents what you see at the center of the Nest Protect, a button with an area that glows different colors surrounded by kind of a grill for the speakers and the air sensors. So we're going to approximate that look. We're going to do it in Flutter using nothing but custom painting. So let's jump into it. As you can see in the simulator here on the right, we have a big red box where our widget will appear. We want to replace that red box with that kind of Nest Protect grill and button and glow. So we'll take this container and we will remove it. We will replace it with a custom paint. The custom paint will take a painter, which we will call the Protect Pattern Painter. And we will allow the custom paint to be as large as it wants to be, which is fine for the width. It's free to take up all available width, but we actually do want to constrain the height. And we want to constrain the height by ensuring that we always paint a square. And we can accomplish that by surrounding custom paint with an aspect ratio widget. And then we can set the aspect ratio to 1. So now our custom paint will take up all available width, but the height will be equal to the width, which is what we want. So let's go ahead and create this custom painter to get us started. As always with a custom painter, we will override these two methods that we need to implement. We don't care about optimizations, so we will always repaint. This paint method is where we're going to do our work, but we need to bring in a few numbers that we're going to use as metrics to decide how large things should be and opacity and things like that. So first, we want a center ring to dots gap. Looking back here at an image of what we're working towards, there's this kind of center ring, and then there's a gap between that and the beginning of these dots that we're going to draw. That gap is what we define right here, and it's going to be 20 pixels. We also need to know how many dots per ring, and you can choose any number you'd like. I'm going to go with 64. That seems to work out pretty well. I haven't counted the actual image in the Nest app, so I don't know what the real number is there. And then for the dot radius, we're going to go with 2.5. And then for the dot opacity, we're going to go with a very low 8%. And at some point here, we are going to need a dot paint to actually create the dots on the screen. In the constructor for now, let's go ahead and initialize that dot paint. The color can just be black, but we want the opacity to be equal to the dot opacity. And actually, I take that back. We can just set it to be black for now, and we will actually adjust the opacity as we paint, because the opacity is actually going to change. So we'll just initialize paint to a normal black, and we'll worry about the opacity down here in the paint method. Now, to get us started with our custom painting of this pattern, we're going to just get one dot on the screen in the correct place. Then we're going to get a ring painted in the correct place. And then we're going to expand out to paint all these other rings of dots. So let's get that one dot on the screen first. Let's start by calculating the center of the ring. We'll take the size that we're given, and we'll ask for the center of that size. So this is the center of our available space. And then the center circle radius, we're going to just choose a number here. We're going to decide to be 1/6 the width. And again, we know that our width is equal to our height, so it doesn't matter which one we pick. But that center circle with the logo in it is going to be 1/6 of our available width in terms of radius. And then we want to draw a single dot. The ring radius is going to be the center circle radius plus the center ring to dots gap. This is the ring. So every dot exists in a ring around, well, let's just go back to the design. Every dot, as you can see, is in a ring. And each one of those rings then has a radius. For our very first dot in our very first ring, this is us calculating that ring radius. And then we could just draw a circle directly, but thinking ahead a little bit, we're going to want to draw many circles. And we can do that with a path. So it may be a good idea for us to just start working with a path right now. So we'll have the dot circle path. And we'll add an oval. We'll create a circle from a rectangle. The center of this first dot is going to be the ring center. And then we're going to offset it. We're not going to offset in the X. So this one dot is going to be drawn on top of or above, directly above the center of this design. We're going to offset it by the negative ring radius. That's what pulls it up. And then the radius of this little dot is going to be the dot radius. Now, I mentioned earlier that we're going to actually set the opacity in this paint method, and we're going to do that right here. So dot paint dot color is equal to its existing color, but with the opacity that we define here. Then we're going to draw the path with dot paint. Let's save that. And I don't know if you're going to be able to see this, but right here, there is one little dot. So we've successfully drawn our one dot that is above, directly above the center of our overall design or circle or ring. With that one dot drawn, we now want to essentially do the same thing 63 more times in a ring, and that will give us our first ring. So we'll do that next. Now let's go from one single dot to drawing an entire ring of dots. Let's come back into our paint method, and where we say draw a single dot, let's just change that to say draw a single ring. Now every dot in that ring is going to be a certain angle rotated compared to the other dot or dots in that ring. Essentially, there's an increment in angle for every dot. And I'd like to calculate what that is because it's never going to change. Let's call it delta angle. And that's 2 times pi, which is the radians per circle, divided by dots per ring. So every time we draw a dot, we want to change the angle by this delta angle amount. Then we know that we want to do some kind of loop from 0 to dots per ring. And let me import the math package so we can access pi. So for every dot in the ring, we want to draw a dot. But now the question is, how do we calculate the correct center position for each one of these dots? We need to somehow rotate it. Now there might actually be an easy answer to this in the Matrix 4 or somewhere in the Dart library. I couldn't find it really quickly. So instead, I'm actually just going to define my own rotate vector method. And this is based on math that you can easily find online. So, and I guess let me be clear about why we want to rotate vectors. We have the center position. I'll use my cursor here. We have the center position of our drawable area. And this dot directly above us, we can look at it as a vector pointing from that center position up to the dot. If we take that same vector and we just rotate the vector a little bit, then we can draw the next dot. Rotate it a little bit more, draw the next dot. That's an easy way for us to go around and create the ring. So if we create a rotate vector method, then that just makes it easy for us to rotate that vector. So we'll take in a vector and we'll take in an angle in radians, and we will return a new vector represented by an offset. And again, this math is readily available online, but we're going to take the cosine of the angle. We're going to multiply it by the x position of the existing vector. We're then going to take the sine of the angle, and we're going to multiply by the y, and that gives us the new x value. Then we're going to take the sine of the angle, multiply by x minus cosine times the y value. That is all it takes for us to rotate a vector. And then we just need to be careful that what we pass in really is the vector that we mean to pass in. Coming back up here to where we draw our circle or our dot, you might initially be tempted to pass this whole thing in there, but we don't want to do that because we want our vector to be based on the center position. So really this part over here is all we care about in terms of the vector. If we take this offset that I have highlighted here and we rotate it, that gives us the effect that we want. So let me cut that, and then I'm going to invoke rotate vector, and the vector is what I just cut, and the angle, it's not just delta angle, it's delta angle times I. It's delta angle based on which dot in this ring we care about. So I saved that, and notice that over here in the simulator, sure enough, we have an entire ring of dots. We have our very first ring. Now we need more rings, and that's what we're going to do in the next step. To get us started with this step, we want to paint multiple rings, so let's extract what we've written for one ring so that it's easy enough for us to configure for multiple rings. Right here we have the logic to draw a single ring. Let's go ahead and just cut all that out. And let's replace it with a call to draw dot ring, which doesn't exist yet, but it will. And I'm going to give it named parameters here in a minute, but it'll take a canvas, it'll take the center of the ring, it will take the dot count, it will take the radius of the ring, it will take the radius of a dot, and it will take an opacity for the entire ring. And we'll take ring radius out of here, I guess, actually, because that's going to change over time as we draw more and more rings. And then, what did I call this? Yeah, dots per ring. Let's make that an integer. It doesn't really make any sense to be a double. We're not going to have part of a dot in a ring. All right, so let me save that. And I think we're still good here. So we're still drawing our one ring, and so now we can adjust some of these properties as desired to draw multiple rings. Coming up here, let's define the first ring radius, which is equal to what we already had here. And let's have a final ring radius, which is going to be, we know the width and height are equal, so we're going to take half of the width. That's going to be the final ring radius. Now, so the angle that, or the perspective that we're taking here is that we're not going to say for sure how many rings there are. We're going to look at our available space, and we're going to calculate the different radii, and then we're going to choose how many rings to paint based on available space. So what we're going to say is we're going to say final ring radius minus first ring radius divided by the ring gap. And it looks like maybe I forgot to define that. So we want to say constantly what the space is between each ring. So we'll come up here and we will say final double ring gap. And that's going to be just 7 pixels between the rings. We'll come back down here and we will divide that difference in our radius by the ring gap. And then we will floor it to give us an integer so we don't go too far. Better to be not far enough than to be too far. That gives us the number of rings that we're actually going to paint, which then allows us to write a for loop. I is 0, I is less than ring count plus I. And then we already have our call to draw dot ring, but of course we now need a new calculation for what our ring radius is right now for this ring. And that's going to be ring radius equals center circle radius plus center ring to dots gap. And then this is the new part, I times ring gap. So when I is 0, that goes away and we're back to our original radius calculation. But as I increments, we add that gap based on which ring it is. So now let's save this. And now we got some wacky looking thing where we have these kind of columns of dots that fly out from the center. Now, obviously this is not what we were going for, but we are one step closer now to our goal. We have all the different rings. It's just a matter of orienting them correctly. So how should these be oriented? I don't know for sure what's done in the real nest pattern, but looking at it, as far as I can tell, all we need to do is stagger every other ring so that the dots of the next ring sit in between the dots of the previous ring. And I'll show you how we accomplish that. We essentially want what I will call, for lack of a better term, half dot rotation. So it's like our normal rotation amount for a dot, but only half of it. And this will cause each ring of dots to sit exactly in between the dots of the ring before it and the ring after it. So we will say 2 pi divided by dots per ring, which is the same calculation we did before when rotating every individual dot, but we're going to divide that by 2. This is going to give us half the rotation between 2 dots. And we want to actually rotate every other ring this amount. I mean, we could rotate every ring more and more and more, but half of the rings would just align with themselves. So, well, I'm probably explaining that in a very poor way. So let me just show you how we handle this, and I think it'll make sense. We are going to require, well, I guess all of these are required. We're going to take in a ring rotation. So we are going to rotate the entire ring by some amount. And the way that we're going to apply that is we know we're already doing this delta angle times I for every single dot. We're going to take that angle and we're just going to add the ring rotation to every single dot rotation, which effectively has the exact same result. If every dot is rotated by ring rotation, then the whole ring is rotated. But then how much are we going to rotate? And actually, more importantly, when are we going to rotate? Well, if I mod 2 is 0, then we're going to rotate by a half dot rotation. Otherwise, we're going to rotate by nothing. So ring 1 is right here where you expect it to be. Ring 2, slightly rotated. Ring 3, back to normal. Ring 4, slightly rotated. And it just staggers that all the way out. And let me show you how pretty the result is of making that very minor change. Now look at that pattern that we have. Just standing back and looking at it, it actually wasn't all that obvious that the pattern was just rotating the rings a little bit every other ring, but that really gives us something that looks remarkably similar to what you would find in the Nest app. So we're making good progress. We have the root of the pattern down. Now we need to handle some nuances in how we paint those dots, and then we want to get something going on in the center here, and we'll do that in the following steps. Before we get to doing the stuff in the center with the glow and the logo and the shadow, I want to make a few modifications to how we're drawing these dots to get a bit closer to the source material and also to remove some of the harshness to this pattern that we're looking at. Let's define and maybe redefine some of these values that we have up here at the top. Instead of having a single dot radius, let's have this dot radius be the start dot radius. And then let's have another radius, which is the end dot radius. And we're going to make that twice as large. So these dots are actually going to grow larger as they expand out from the center. And let's do the same thing with the opacity. Let's have a start ring opacity, or I suppose to follow the other property, we can call it start dot opacity. And then we can have an end dot opacity, and that one's going to be much lower, 0.005, 0.5% of opaqueness. So they're going to be barely visible at the final ring of the pattern, which is what we want. So let's go ahead and get this spectrum of values worked into our pattern. You can see down here in draw dot ring, that's where we pass those values in and they no longer exist. So for the dot radius, we are going to use lerp double, so linear interpolation, and we're going to go from the start dot radius to the end dot radius. And for the percentage, we can create something called, let's say, ring percent, and we can set that equal to I divided by the ring count. We can pass that in here, ring percent. For the opacity, we're going to do something very similar. Lerp double, start dot opacity, end dot opacity, ring percent. And let's see what I've broken down here. So this dot opacity should actually be using this opacity that we're passing in. So that was a mistake I made earlier. But with these lerp changes, let's notice what happens over here on the simulator when I save. All right, so I just saved, and you can see that everything gets much more obscure towards the boundary, which is what we want. So it's very clear to see the dots near the center, and then they expand, they grow, and they fade out. And that's what we're going for. So we're looking pretty good now on the pattern. And in the next step, we're going to introduce a shadow in the center, and then we're also going to eventually add a glow. Conceptually, at the center of this nest protect looking skeuomorphic concept, there's supposed to be a button, and that button actually extrudes out from the center. And so there should be a minor shadow around the exterior of that button, and that's what we're going to add right now. Now, to actually paint a shadow, we need a paint to do that. So let's come up here and let's create a shadow paint. And then we'll come up here in the constructor, and we will set that equal to a new paint. The color is going to be black with an opacity of 40%. And here's the important part for this particular paint. We're going to set an image filter on this paint. And it's going to be equal to imagefilter.blur, and we're going to blur both dimensions by 2 pixels. And that's what's going to give us the appearance of a shadow. Now in our paint method, we'll go ahead, we'll add a draw shadow method, and we're doing that before we paint the dots. It doesn't really matter, they don't overlap, but we'll go ahead and do this first. And what we're going to end up passing in is a canvas. We're going to pass in the drawable area, which is going to be size. We're going to pass in the center point, which is the same as the ring center in this case. And the center circle radius, we've already calculated that as well. So we're going to paint a shadow at the center with a radius, starting at a radius of this center circle radius. So let's go ahead and define this method. Now, first, let me show you what isn't going to work, and then we'll look at how to adjust things so that it does. Let's go ahead and take the canvas, and let's just draw a circle on the canvas. And we'll draw it at the desired center. We'll give it the radius that we want, and we'll use the shadow paint, all of which sounds pretty reasonable, except notice that that gives us a full-blown, it's a shadow as if an entire circle were sitting above the screen. But that's not actually what we want. We want the shadow as if it's spreading out of a white circular button right there in the center. Now, I suppose that we could just draw a white circle above this shadow. The challenge then becomes, what if the color of the screen changes? Then you always have to keep that center circle displaying with the same color as the rest of the screen. And those are the kinds of things that tend to fall out of sync, and they become really embarrassing screw-ups when you ship to production or something like that. So what we're going to do instead is cut the center of this shadow out. We're going to define a path here that I'm going to call the mask path, because we're going to mask out some of what's drawn. First, we're going to add a rectangle that takes up all available space, because when we're cutting something out of something, we need to know what the bigger size is, and we can't just say infinity, unfortunately. So instead, we're just going to create a rectangle that takes up all of the available space. So from 0, 0 to drawable area dot width, drawable area dot height. We're going to add that as a rectangle. And then we're going to add an oval, which is actually going to be a circle. The center is going to be the center that we're given. The radius is going to be the center circle radius. And then the key to this being a mask, the key to using this to cut things out, is to set the fill type equal to path fill type even odd. This results in our oval being cut out of the rectangle. And then we can use canvas.clipPath, pass in the mask. Now let's save it. And now we have a shadow. Now it looks like there's a button at the center of the screen with a little bit of shadow. And even if we change the background of the whole screen, that center area will change right along with it. And now there's really only two things for us left to do. One, to stick a logo in the center to make it look kind of neat. And then two, to add a green glow coming from underneath that button. And we'll do that next. I'm going to very quickly throw my logo in here so we have something cool to look at the center of our design. But obviously this is not something you need to worry about. I'm just going to paste in some details here, paste in some colors. I'm also going to paste in a method to build my logo. And then the only thing that we're going to do here is we're going to come up to where we have our custom paint, and we're going to surround it with a stack. And then, we have what we're painting in the stack, and then on top of what we're painting, I'm going to center my logo, save, and now we've got that semi-skeuomorphic logo in there as well to give us just a little bit of detail there at the center where clearly we needed it. And next what we want to do is actually begin painting a glow beneath that center button. To paint a glow, we're actually going to leverage two paints. We're going to paint actually two glows. We're going to paint kind of a primary glow, which is the stronger of the glows, and then a secondary glow, which is a bit weaker. In our list of properties here, let's go ahead and add a, we'll say light ring paint, and then a light ring glow paint. And they're both glows, but this one here, maybe we'll give it a different name. Maybe we'll call this primary glow paint, and we'll call this one secondary glow paint. Maybe those are better names. And also while we're here, we will define the primary glow thickness, which will be 6, and the secondary glow thickness, which will be 7, which is not much difference at all, but they are going to have different blur amounts. Up here in our initializer list, we need to initialize these paints. Primary glow paint. We're going to set the color for this one to this crazy number, 83DB0F. And we're also going to use an image filter. We're going to blur both of these rings that we draw, and that's what actually makes them look like a glow. So for this first one, we're just going to blur it 2 pixels along the X and the Y. And I should point out that this is a color. All right. And then secondary glow paint is also a paint. This one for a color will be FFACFF26. And both of these are versions of green, as you can see on the left bar. And again, we want an image filter, but this time we're going to blur a lot more. We're going to blur 15 pixels. So we've created our paints. We've logged how thick we want the rings to be. And when I say rings, the shadow that we drew is technically a ring. It's a circle with a smaller circle punched out. We're going to do the same thing for the shadows, for the glows, except they're going to look colorful instead of dark like a shadow. In fact, we're going to do it in the same method. We're going to rename this to draw shadow and glow because we're going to reuse that mask. So down here in our renamed method, we just need to draw these 2 glow things as well. And we're going to draw them beneath the shadow. Not that it really matters what order we define the paths, but we're going to define the paths in the same order that we draw them for ease of reference. We're going to start with the primary glow ring. Technically we could draw these directly to the canvas, I think, because we're clipping the canvas, but for symmetry, I'm just going to go ahead and define these as paths. Although I take that back. We are already drawing the shadow as a circle. So let's see if we can get away with that. Let's see if we can draw these glows as circles. So I'm going to copy this one, and the center is the same. The radius, we're going to add the primary glow thickness on top of the radius. And of course, we want the primary glow paint. So this is the primary glow. And then we're going, actually, let's draw the secondary glow first, because technically that should be under the primary glow, if you think about it. So we create this mask, we clip the canvas with the mask, then we draw the secondary glow, which is blurred the most, then we draw the primary glow, which is blurred less, and then we draw the shadow, which is a darker color and even a smaller radius than the primary glow. So let's go ahead and save that and check that out. Let's compare to the screenshot we were going for. So I'd say we nailed it. And it's pretty cool what you can do with custom painters. They're pretty powerful. Whether it's the ability to draw wherever you want, the ability to blur, to control blend modes, all these kinds of things are available to you in custom painters, which is probably why I find myself using them so much. So we've now achieved the kind of default appearance something very similar to what you would see in the default appearance for a Nest Protect in the Nest app. And one last thing before we wrap up this workshop, if you'd like to extend beyond this and you'd like to see how to take the UI that we just created and get pulsing animations, like pulsing glow effects of different colors, and even work in a dark background to complement the light background, I'm going to make additional videos available that explain how to accomplish these goals in an extended widget workshop. And that's available on my website, superdeclarative.com, for about the price of a cup of coffee. So with that, we'll call this widget workshop complete, and I'll see you in the next one.